Okay, geometry kids, this is 2-9, but I have some announcements beforehand. So here's the deal. I'm going to be gone tomorrow. So what's going to, and the 210 section, we will do the 210 section, but so that I don't have to record a video, what I'm going to do is rather than do 210 tomorrow, I'll give you the chapter review for chapter 2. Does that work? And then tomorrow you can spend time in class working on the chapter review, because I think you can do like all of the problems except for maybe like a couple of them from section 10. Okay. So I'm going to give you the review. It's kind of going to be weird. Going to give you the review, and then when I come back on Friday, then we will do 210. And then we'll review probably Monday of next week, and then maybe test Tuesday of next week over chapter 2. So there's that, okay? So that's kind of weird things that are going on. Section 2.9, proving lines parallel. This is not a hard section, and it's kind of like redundant. It's like stuff that we've already talked about before. So you do need your blue sheet, and we are on the back side of your blue sheet. I'm going to erase some stuff that we wrote this morning. I forgot to erase. You do need your blue sheet, your theorem sheet, and I'm going to jump right into parallel lines, okay? So here's the deal. At the top of this paper, I'm going to put 2 lines up here, and I'm going to do a transversal that crosses between them, okay? Now, we've talked about these concepts before and everything, but now we're doing everything kind of backwards a little bit, okay? We don't know that these 2 lines are parallel. We're like, are they parallel? Maybe, question mark. Parallel, question mark. We don't know for sure, okay? But what I'm going to do is I'm going to give you the measure of 2 angles, and let's call this angle 1 right here, and let's call this right here, let's call this angle 2, and we're going to say that each one of those is 100 and let's say 40 degrees. They're each 140 degrees, okay? Now, if they're each 140, do those 2 lines have to be parallel? Yes, right? So before we were saying, okay, if these lines are parallel, then these 2 angles have to be the same. But now we're kind of working backwards, and we're saying we don't know necessarily that those 2 lines are parallel. But according to the angles, is that enough to say that they are parallel? And it's kind of working backwards, okay? So that's what this one is saying. This is the converse of the corresponding angles. And it just says, like, if we don't know that these are parallel to start with, we can look at the angles. And as long as angle 1 is the same as angle 3, those are corresponding angles, right? If those 2 are the same, then we know that they're parallel for sure, right? Okay, so go to your blue sheet and let's fill that out. That was theorem or postulate 213. Go to your theorem sheet. This is on the back side. We talked about corresponding angles, and we said if they're parallel, then the corresponding angles are congruent. Now we're going to say if the corresponding angles are congruent, then they're parallel. So that is postulate 213. We're going to write it off to the side over here, and I'm just going to say that these are the converses. Okay, converse is the backwards, right? So we use this stuff to prove that lines are parallel. This is like if we don't already know that lines are parallel. This is what we use to prove that. A-L-L-E-L, there you go. To prove that lines are parallel, okay? These ones are if they're already parallel. If they're already parallel, this is what happens, right? If they're already parallel, I know that corresponding angles are the same. But if I don't know that they're parallel, but I do know the angles, if they're the same, then they are parallel, right? That's kind of like backwards. So this is not new stuff. It's just like the backwards of it, okay? All right, so let's go back down. We're going to skip this construction. We might do some constructions eventually at some point. Postulate 214 is not something that we're going to write down, but here's what this says. Are you ready? This is kind of silly. All right, if we have a line, like this line down here at the bottom, and I have a point, okay? That point right there, P, we can draw a bunch of different lines that go through this point right here, like all of these lines we can draw through this point. But there is only one of those lines that I draw that is parallel to that bottom line, and it is that one, right? That seems kind of silly. If we have a line on the bottom and we have a dot, we can draw a bunch of lines through that dot, but there's only one of those lines that is parallel to the bottom line, right? Okay, and that kind of makes sense. We're not going to write that guy down, but let's go down to these guys here, and this one is alternate exterior converse. This is the consecutive interior converse, the alternate interior converse. Those are three that we have that we're going to put on our sheet, but we're just going to write the converses on this. So here's what this says. We don't know that these two lines are parallel, but if angle 1 is the same as angle 3, like let's say they are both 70 degrees. If they are both 70 degrees, does that make those two lines parallel? Yes, because these are alternate exterior angles. So that's just saying the converse. We're trying to prove that they're parallel. That's the converse, okay? Let's go down to this third one, okay? Here is my two lines. I don't know that they're parallel, but if I say that 8 is, let's say, 60 degrees and angle 6 is also 60 degrees, do those two lines have to be parallel? Yes, because so those are alternate interior, okay? Now let's go up to the middle one. We don't know that these two lines are parallel, but we have angle 4, let's say, is 60, and angle 5 is 120. Okay, those aren't the same, right? But with consecutive interior, they're not the same. They have to add up to be 180, and those do add up to be 180, so do those two lines have to be parallel? Yes. So that's kind of just saying the opposite of what we already know, okay? So let's go up here. And alternate interior angles theorem, this is theorem, and I don't remember, which one was the interior one? 222? Yeah, 222. Alternate exterior was theorem 220. And consecutive interior was theorem 221. Okay, so those are just saying the opposite of what we already know, right? If we don't know the lines are parallel, we can use the angles to show that they are, right? That's just kind of how that works. So rather than rewriting them, I'm just going to do the converse on that side. Okay? I'll let you get those written down. Okay. All right, so let's answer some questions now. They give us some stuff and we have to do some math here. Oh, wait a second. The last one, 223. We have to do we don't write this one down, but we're going to talk about this one. Okay? So this one says, we don't know that P and Q are parallel. We don't know that. We don't know that these are parallel. But we do know that this transversal makes a 90-degree angle with the top one, and it also makes a 90-degree angle with the bottom one. If that is true, do they have to be parallel to each other? Yes. So that's like the converse of that one, right? The converse of the perpendicular transverse. Okay? All right, now let's answer some questions. So here we go. We've got this diagram over here, and it doesn't tell me that any of those lines are parallel. Which ones probably are parallel? LM and N. Possibly those are parallel, right? P is the transversal, right? But LM and N, we're going to say possibly are parallel. All right, so given the following information, is it possible to prove that any of the lines are parallel? If so, state the postulate or theorem that justifies your answer. So, I don't know that any of those lines are parallel, but I do know that angle 1 is congruent to angle 6, okay? So if that's the case, ignore M as that parallel line, was we're only looking at L and N, right? So if I say angle 1 is the same as angle 6, is that enough to show that L and N are parallel to each other? Yes, so we would say that L is parallel to N. That's my symbol for parallel. L and N are parallel because of what? What are 1 and 6?
Alternate exterior.
Those are alternate exteriors. So the alternate exterior converse, if you want to write that, or you can put theorem, what was that, 220? Okay, either one of those are okay, right? So if this is true, then this is true because of this, right? If angle 1 and angle 6 are congruent, then L and N are parallel because of the alternate exterior converse. Does that make sense? Okay. All right. Next, I'm going to erase all my information over here, and now we're saying that 2 and 3 are congruent. Okay. So over here, I'm going to switch colors here, though. Angle 2 is congruent to angle 3. So now we're going to ignore this bottom stuff right here. Okay. If 2 and 3 are the same measure, is that enough to say that L and M are parallel? Yeah, because, yep, L is parallel to M because of the alternate interior angle theorem. Alternate interior converse. And that one was theorem 222. There he is. Just like that. Okay, happy with that? Not too bad, right? Pretty easy. Okay, now example 3 is going to make us do a little bit of math. They say find the measure of angle MRQ. So we're going to have to be doing some plugging back in. MRQ is this angle right here. MRQ, that guy. Okay, and he is 5x plus 7, but they want us to find that so that this line is parallel to this line. Okay, and those two lines will only be parallel if what? What about the 5x plus 7 and this guy? If those are the same? Yeah? If those are the same, so those have to be equal to each other if the lines are parallel. So 5x plus 7 has to be equal to 7x minus 21. Oh, 21. And how do I know that those two have to be the same? What are those in relationship to each other? Those are alternate interior. So that's the alternate interior converse, which was theorem 222. You don't have to put both of those down on your homework assignment. You just have to put one of them. For me, it makes more sense to say the alternate interior converse because then I don't even have to look it up on the sheet, right? Does that make sense? But if you want to look it up on the sheet and say theorem 222, I'm fine with that. So now we have to solve for x, okay? So I'm going to subtract the 5x, and I'm going to add the 21 at the same time. So 7 and 21 make 28, and 7 minus 5 is 2x, and let's divide by 2. So x is like 14 maybe. Okay, but they want to know the angle, the measure of angle MRQ. And MRQ was the 5x plus 7. So I take 5 times 14 plus 7. 5 times 14 is 50 plus 20 is 70. You guys multiply like that sometimes? Yeah. 70 plus 7, so that angle MRQ is 77 degrees. Okay, so be careful. Sometimes they will make you plug it back in. Sometimes they just say solve for x. So just pay attention to which one that is. Okay, all right, so we have a picture of a ladder here. I don't know, you might not be able to see it very good on your sheet because it's kind of like dark. But you have a ladder, and these two lines that go up and down, those are called rails. These are called rails. I'm trying to like think of what these are. Okay, and then the ones that go across, these are called rungs. Have you heard that before? R-U-N-G-S, okay? And then they have like little boxes right here that show that those are perpendicular to each other, right? Perpendicular, 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 right? Okay. Now, we know that the pink ones are perpendicular to the blue ones, right? But is it possible to prove that the two rails, meaning the two that go up and down, are parallel to each other? Do they have to be parallel to each other, right? Otherwise, we're going to have a really wonky ladder. That's going to be really bad, right? So those two have to be parallel to each other because of the perpendicular. So I'm going to say yes, they are parallel. They are parallel because of the perpendicular. Is it the perpendicular something?
Parallel postulate.
I'm looking at the bottom one, though. On the sheet. The perpendicular is it transverse or transversal? Transversal.
A lot of ladders aren't though.
Converse. What?
There's a lot of ladders that aren't parallel.
Okay, but hold on. Here's the deal. Okay, so the ladder that you're probably thinking of is a ladder that maybe looks like this, right? Like, and the rungs are going this way, right?
Yeah.
But if that's the case, is this perpendicular? Are those perpendicular? No, they're not making a 90-degree angle, right? So they're saying if they're making a 90-degree angle, right? If they're making a 90-degree angle, there's no possible way that these two cannot be parallel. Yeah, so I get that. This is like a thing. Sometimes they'll do ladders that look like that, right? That are like not, they're wider at the bottom and then narrower at the top, or vice versa, whatever. But those wouldn't be perpendicular on the angles where they cross, right? So the perpendicular transversal converse tells me that those two have to be parallel, which makes sense, right? That's it. That's all I have. On your homework assignment, I don't have it here, but we're gonna do odds on both sides. Odds both sides, and there is one proof that you will have to do. You can attempt it on your own. It is a fill in the blank proof, but if you struggle with it, we will go through proofs on Friday when I am back. Right? Okay. So on the test, I think I give you one algebra proof. You know what I'm talking about with algebra proof? Like I say, here's your algebra, and then you use subtraction and division and whatever, those things.
Okay.
Those ones are very nice. And then I think I give you one other one.
Do they have the fill in the blank proofs, or is it like?
I don't remember. I'll look and I'll make sure I forewarn you before you take
I
this test.
definitely don't like the
Because
fill in the
I'm
blank
not gonna
proofs.
do
You don't like the fill in the blank proofs?
Actually, I just don't like
They're
proofs,
better than the
period.
normal
But
Anyway. So, odds both sides, if you're watching this video, there you go. On the homework assignment. Skills practice, practice, odds both sides. There's one proof. We'll do it on Friday together, but try to attempt it maybe by yourself. And there we go. Everybody say bye.